Well, good morning, good afternoon, whenever you're watching this video here in Pre-algebra. We'll go ahead and just get started here, jump right into it. And then next week you guys get to see your midterms and everything. You should have seen your grade pop up on Google Classroom. And then before I start, just a reminder, okay, that if you need to get any tutoring, just pop in on Friday. I have a couple extra sessions there for you to ask questions, but you can always email me if you need to as well, okay? But week 19, we're going to start out with our supplement. Okay, so week 19, and there we're just looking at reviewing equations. Okay, so what equations are. So this is just an equation review supplement. Okay, and then what you see there is that they're asking you right at the beginning, label each equation as true, false, conditional, right? So when we talk about true equations, right, if I have a true equation, right, this is the normal type we're used to, right? I have 8 plus 4, and then over here I have, I don't know, 10 plus 2, right? If I have that, then I have 12 equals 12, and that equation is true, right? Otherwise, I could have a false equation, right? Seems kind of dumb to have it in the first place, okay? But I have a false equation. It's like if someone said to you, right, and they're like, oh, 2 plus minus 3 equals 5 or something, right? So first glance, you're like, oh yeah, right? But it's 2 plus 3, right? But it's 2 plus minus 3, right? So what I have to remember, right? These are separate numbers here, right? I have 2, which is plus, so it's like I have $2, and then this plus is like I'm spending, and then I have a minus 3, right? So I have 2 plus minus 3, so I'd end up having minus 1 equals 5, right? And I can see that's false. And the last one is conditional, right? So conditional, right? So just like your parents, right? And they're like, well, we can do this if you finish all of your algebra homework or something, okay? But conditional, right? I can start with something simple, right? I can say 2x minus 5 equals 15 or something like that. If I do that, then I say, okay, well, in order to do this, right? And let me see here if I can scroll down. I think I can scroll down here, but yeah, there we go. Then, right, to solve this, right, we said our equations are balances, right? So this equal sign in the middle is a little balance, right? So you know what a scale is that balances maybe, right? So then over here, I'm going to say, well, I want to find x, so I'm just going to add 5 to both sides, so plus 5. And then when I do that, right, so this is like my dividing line here. Then over here, I'll have 2x left, and it'll equal 20. Right, and now at this point you can see that I divide both sides by 2, right, because this is 2 times x, and then I have 20. So then I do, okay, well, let's divide 20 divided by 2, right, and say, okay, well, then x is equal to 10. Okay, and those get a little more complicated when we have just more things to move around, but the same procedure is still the same, right? So you guys have a little bit of instructions on your paper if you need help there, right? But if I have something, let's go ahead and just do one more real quick example. But if I have, I don't know, it doesn't really matter what it is, but if, let's just say I have 5c plus 5, and then over here, right, I might have 10c, okay, and then if I have 10c over there, right, then what do I have to do to figure it out? Well, I guess the part that's a little bit hard is that it's like, well, I have C in both places, what do I do? We're going to find one place for C to be, right? So I'm going to assign either side to have the C's, but I like to think of it as, well, what's the least amount of work, right? I want to get all the C's on one side and all the numbers on one side, right? So I want numbers on one side, I want my variables on one side. So this side over here, okay, this side would be the easiest to put the C's on because I just have to move this number here, right? So the opposite of having 5C is minus 5C, so I'll do minus 5C. So I wrote this C smaller, but it doesn't really matter. Okay, just to see it clearer, right? Maybe I should have written it bigger in the first place. and then I'll have 5 on this side. If I have 10c, just like if I have 10 of anything, right? 10 of something minus 5 of something, I'll have 5 of those c's, right? And then I divide both sides by 5, right? And then it's easy to see that I'll have c equals 1, right? I could say c equals 5 over 5, but 5 over 5 would just be 1 as well, okay? So that kind of completes the supplement there. So if you have any questions, definitely let me know. But I think that's the basics of it, right? So just go ahead and do that as a review. Just remember also our negatives rule, right? If you're dividing negatives, right? So let's change the color so I don't get confused with this one, right? But if I'm dividing negatives, so if I have minus 8 and I'm dividing 2, right? That's considered an operation, right? This is an operation in itself. So when I do that, right, I have one negative as part of the operation. So when I divide this, I end up with minus 4 because it's just an odd number of negatives versus if I had minus 8 divided by minus 2, right? I have two negatives, so I have two negatives, right? So anytime I have a pair of negatives, they cancel each other out. So then right here, I'd have plus 4, okay? And it's never a bad idea to write plus in front of it just to remind yourself what sign it is, right? We know that if we see anything like this right here, up here, that's 5 or whatever, these are positive, right? Because they don't have any negative sign in front of them, okay? It's just extra work to write them, but it can be good to write for clarification. Okay. So let's go ahead and move on to lesson 69. So lesson 69 is about order of operations to some extent here, or not order of operations rather, but a different form of numbers here we call absolute numbers. Actually, no, I'm reading now. It says adding sign numbers. So there's a little bit of not order of operations, but I'm talking about how to add multiple sign numbers. So absolute value. Okay. So absolute value is very simple because if I have a number here, right? If I have the number negative 5, okay, I put these just vertical lines here. So these aren't ones or anything, okay? These are just vertical lines, so I can make them thicker to show it, right? This means find how far my number is from 0. And you say, well, it's minus 5 from 0. Well, absolute value doesn't care, right? It just says how far is it from 0. I don't care if it's negative or positive, just tell me, right? So basically it just knocks off your negative sign. So I have 5, right? Same thing, right? If I had positive 5, right? If I said, what's the absolute value of positive 5? Well, it'd just be 5, okay? So it's just getting rid of that negative sign. Okay, so if I had, right, if I wrote this like this and I said, oh, well, what is the, if I'm going to say negative 5, right? And you say, oh, well, this negative here, right, this one is separate. So then I'd have to say minus 5, and that would be my final answer or something like that, right? If we got to something that was a little bit more complicated like that, okay? We're just introducing absolute value because we want to think about adding these a little bit later, okay? But let's talk about an example here that's not in the book here. But example, we're gonna add on number lines. So I guess I could say absolute value and also adding on number lines. So adding on a number line. Okay. So we've done this before. So it's a little bit of review, okay? But if we said, let's do minus 5 plus 7, okay? So minus 5 plus 7. So the first thing we want to do, okay, so I don't know if I want to label these, right, but the first thing I want to do, maybe I'll just do it in blue, okay, I want to go ahead and just think about what's going on here, right? I'm starting, this is always my starting point, minus 5, okay? So I do want to make sure I start my graph at that point, okay? And then think about what my second number is doing, right? Well, my second number, I'm adding to it, okay? So I'm not subtracting from it, adding to it. So if you think about it visually, right, it's like I'm starting somewhere like on over here, and then I'm going over that way, right? Okay, so let's just think about that as in terms of a number line. So in terms of a number line, there's my nice kind of straight line here, right? I'll be over here at -5, okay? And I'm adding 7, okay? So if I owed somebody $5 and then I gave them $7, say, you know, for all the trouble of borrowing $5, I'm gonna give you $7, right? So then you say, okay, well, I added 5 back, so that would have been 0. And then I went 1, 2, I went further, right? I went further than they were asking me to go, right? If I owed them $5, I gave them 7, okay? So I can put -1, -2, -3, -4 if I want to, okay? But that's basically my number line. And then I just want to start somewhere, right? Where am I starting, right? Because I'm not done with my number line. I just want to start here. So I'm going to start here at -5, and then I'll just show with an arrow that I'm going over here, right? And then I can put a line, a vertical line here, just to show that that's where I'm going to stop. And then I can write +7, okay? So this graph right here, right, tells me everything that this one above tells me. It's just a little bit more detail and just a little bit more visual, okay? So let's talk about one other thing here, right? If I'm going to talk about adding numbers here, another example, so this one's also not a scripted one in the book here, right? But if I have negative numbers, okay, if I'm adding negative numbers, I guess you could put that here, but adding negative numbers. There's plenty of other things we can do, right? But a lot of things we do with negative numbers. Let's just start with a simple one, right? So if I have -8, and then I say plus -17, okay? So I could use a number line for this, right? But the purpose of the number line is just to get our heads kind of in the right place as far as thinking about what's happening, right? So if I think about this in terms of a number line, let's just, I don't know, just do a pretend one, right? So we say, okay, well, if I'm at -8, right, I'm somewhere maybe here, right? I'm just going to be in green here. And then if I'm adding -17, right, I'm going over that direction, right? So my numbers are working together, right? So when I do this and I say, oh, well, if they're working together, right, they're becoming more and more negative, right? So then in this case, I say, okay, well, I'm adding 17 to 8, right? So I can do this in a number of ways, right? I can just say, oh, well, I know 8 plus 17 is 25. Or, right, I don't think I probably have to line these up anymore, right? You guys, actually, I didn't mention this, right? But you guys can use your calculators now. Okay, so if you don't have one, get a scientific calculator like a T. It's called like a Texas Instruments 30. Okay, so maybe I'll put that here. TI 30 or something like that. You can look it up. So capital letter T, capital letter I, /30 series, something like that. Okay, it'll work, right? But anyway, back to this, right? I added those numbers together, right? And I got 25. So you think, oh, I'm done, right? But if we think about what happened right up here, right? It's like if you work in accounting or something, a lot of times they'll color code things, right? And if they put numbers in red, they mean it's negative, right? So let's just say, for example, I spent $8, right? So, or whatever, right? I spent $8 and I spent $17, right? Then I'm going to owe somebody $25. So I'd put -25 for my final answer, okay? Now, I guess I'll just do real quick, right? If I had multiple numbers here, let's just say I have -8 plus 2 plus -5 plus 4, okay? Right? One way I can do this, I can do one at a time, right? And I can go just from left to right like this. Or what I can do, we've talked about this before, right? I can just say, well, you know what? This number here is negative, this number here is negative, and this number over here is positive, and this number is positive, right? So let's add my negatives up. So I say, okay, well, -8 and -5, that's going to be, whoops, That's going to be minus 13, right? I just added those two up. And then my positive numbers, I have plus 2, plus 4. Then I have plus 6, right? So if I have minus 13, right, and say, okay, well, I'm starting negative, right, and then I'm adding 6. So if I think about the absolute value here, right, so this is going back up here, right, absolute value just zeroes out the negative there. My first number, right, minus 13, has a larger absolute value, right? It's farther from 0 than 6 is, okay? It's just in the negative direction. So if I was going to plot it on the graph, right, and you say, well, if I'm starting over here at minus 13 or something, right, and I add 6 to it, oops, and I add 6 to it, I'm not going to get all the way to 0, right? 0 is still going to be a destination there because I'd have to add, right, this would have to be plus 13, and then I'd be at 0, okay? So when I think about this final answer, right, and so I'm kind of erasing this, but I guess maybe I'll draw a better sketch here, right? If I was at minus 13, and I said plus 6, right, and I say, okay, well, let's think about this, and I say plus 6, right, and you say, oh, well then, you know, it's like doing 13 minus 6, right, and making sure the number is still negative. So I'd be at minus 7 as my final destination there, right? Okay, minus 7. All right, so hopefully, right, I didn't belabor the point too much, but hopefully you guys understand that, right? And then let's go ahead and you can pause it and work on some practice problems, but we'll go on to lesson 70. Okay, so lesson 70. Yeah, and so a second. Do you down a little bit? Okay, just a second. Hopefully you guys don't hear too much in the background, but anyway, so lesson 70 here. Now we're going to talk about adding a collection of numbers. Okay, so collections of numbers. Okay. Right, we have, I guess I'm applying what we learned in 69 again, okay? But we could sum it up like this, right? We say 1, right? We could go ahead and add all the negatives. And we'll add all the positives, okay? So some of you guys are like, okay, I know what to do, right? But it's worth writing out, okay? Just because I wanted to make sure we understand how this works, right? But we'll say add all negatives, add all positives, and then we'll add the two sums, okay? So add the two sums. So, example 1, here they have multiple numbers here, right? You have minus 4 plus, and for some reason, right, they put these parentheses, right? But they put the parentheses here plus plus 3 just to make sure we're paying attention to what's going on here, right? And then plus minus 5 plus 7. Okay. I think this is a little elementary, right? We'll go through it quickly, right? But then we say, okay, well, if I'm going to follow these rules here, right? Let's look at what the negative numbers are, right? So negative, we'll put them in red here. This one's negative. This one's negative, right? There's two negatives, and then there's positive, right? So let's do the green for the positive, right? Green is positive. So if I add all the negatives, I have minus 4 and minus 5, right? If I add 5 and 4, it gives me 9. And then I just say, okay, well, that's minus 9, obviously, okay? And then for my green, or my positive number, right, I say, okay, well, I have 3, I have 7, that's 10. So I just say plus 10, right? So if we think about what's going on, right, that's like I owe somebody, right? I owe somebody $9, so we can say it's minus 9, right? And then I'm giving them $10. So I think we would know, right? And then we end up with plus $1, right? I'm just putting dollars in here just to make it sound or seem a little bit more concrete here. Okay, so that's all that's happening there, right? So plus 1. So what's the important part here, right? Is that you always focus on the sign that's in front of your number, okay? That sign, these signs, these are both positive, right? So positive, right? If I say I want to go somewhere, I want to go somewhere, right? And that doesn't conflict with what you're saying, right? Whereas if you say I don't want something, right? And then you say I don't want something, I don't, I don't know, something like that, okay? But then I have plus, right? So it's like I'm spending a negative amount. So I'm focused on this, and I have one negative, right? So the number 1 is an odd number, right? It's an odd number of negatives, so it just becomes, right? I could have written this as -5 instead, okay? Instead of plus -5, it could have just been -5. So that's going to be minus, and over here I have plus, right? So it's just the same thing that I have for my +3 over here, okay? All right, and then let's go ahead and look at lesson 71. You guys can do some practice, and then you can pause the video, come back, play it again, okay? But we're in lesson 71. Okay, so lesson 71, powers of fractions. Okay, so powers. Okay, you guys have been acquainted with powers a little bit. Okay, we're getting to a little bit more here. Okay, and then we're going to talk about roots of fractions too. So and roots. Okay, so let's go ahead and just talk about what a power is, right? So you say, okay, well if I say 2 and I say to the power of 3, right? Well, what does that mean? Well, it means that I'm going to do I'm going to multiply the base by itself 3 times, right? So I'm going to do 2 times 2 times 2, right? So that means I'll have 4 times 2, and then I'll have 8, right? Okay, so really with fractions, there's not anything complicated going on, right? I just am going to go to my example here, example 1, and if I have 2/3, right, and then I say it's raised to the 3rd power, right? It's just like my example up here, right? It's very, very similar, right? It just looks a little bit different. So for my 2 up here, let me just go ahead and put parentheses around it. Maybe you'll see some similarities, right? If I say that, you say, oh, yeah, my base is 2. So if I look at my expression down here, right, and say, oh, well, then I'm just doing 2/3 times 2/3. Sorry, my times doesn't look very much like times. It's 2/3. Okay, and then what's happening? Well, I'm doing 2 times 2 times 2 on the top, which is just what I just did up there, right? So I have 8 on the top. Let me scroll down a little bit. I have 8 on the top. Then for the bottom, I'd have 3 times 3, right? So that'd be 9. And then I'm doing times 3. That doesn't look very good. Like a 3, okay, 3. And so then I'd have 8/27, okay? And that would be my final answer. So you can write it out like I did up here, okay? You write it out like you did there, or you just know, right? And you're like, oh, well, then it just means that I'm just going to take this 2 and multiply it 3 times. I'm just going to take this 3 and multiply it by itself 3 times, and then I'll have my final answer, right? So it's easy to see how you could just get straight to this without writing out too much, right? Unless you need to write out for this one, right? But definitely you don't need to write out like I did this first part right here. But if you need to write out some of these things, that's fine. And you can always, right now you use your calculator, you can use these things to double check your work. Okay, now for example 2. So example 2, we're going to talk about roots of fractions. Okay, so if I had square root of, actually, before I do that, right where example 2 is, let's just talk about square root. So if I had the square root of 25, what am I really asking about here, right? Well, a square root, right? So if you think of a square, right? I don't know if that's the best way to talk about this, okay, but a square, right, it has all the same sides, right? So if I say that the square has, an area of 25, right, then you say, oh, well, then each side must be 5 long, right? So it's 5 times 5. So here, it's the same thing, right? A square root is asking for a number that I can multiply by itself twice to get to that number. So the equal sign doesn't look very good. Okay, so here I'm telling you, right, if I solve this, I say, oh, well, that's obviously the number 5 because 5 times 5 is equal to 25, okay? All right, so if I went to this example and said, okay, well, square root of 9 over 16, okay? So the tricky part about this is that it looks like, oh man, I gotta do a fraction here, right? Well, the nice thing is that you just have to separate it, right? And you just say, oh, it's the square root of 9 on the top and the square root of 16 on the bottom. Okay, so then when you solve it, then you have 3 on the top and you have 4 on the bottom, right? Because 3, right? If you do 3 times 3, you'll get to 9, right? And if you do 4 times 4, you'll get to 16. I guess I didn't, the 8 arrows, okay? But you can see that, right? So you can just break it down like that, and it works, perfectly fine if I wrote something else like this. So that's my example right there. That's the one that was in that book. But if I, for example, did, I don't know, square root of 20, okay, over 16, right, which we'll do later in algebra, right, and then you can say, okay, well, the top there's no perfect whole number that works for that, so I could just leave it like it was, and then for the bottom, I'll have square root of 16, right, so the top just stays square root of 20, right, and then the bottom is 4, okay, something like that, okay, because we learned, right, all of our numbers, right, 4 times 4 is 16, 5 times 5 is 25, right, and then, right, I think we talked about making sure you learn these right here, right, 8 squared, 9 squared, make sure you know what all those are, because when we're solving equations or solving these roots, then it'd be nice to have those handy. It just makes the math a lot faster, okay? Okay, so on to our last lesson for the week. So we talk about graphing inequalities, okay? So, hopefully that didn't mess anything up here. I need to get a sip of water here. Okay, so lesson 72. It's just about graphing inequalities here. Okay, so graphing. So, we talk about inequalities. You guys have seen inequalities before, okay? Right, you've seen maybe more with numbers here, but if I had an inequality here, as simple as something like if I have two numbers here, right, and said, oh, well, can you tell me which one is larger, which one is smaller, right? Obviously, right? But then you use this symbol here, you've seen before, you could use this symbol that's a little alligator's mouth. You say, okay, well, 6 is larger than 4, okay? So you've seen that before. So I could say, right, and we know that 6 here, right, this is further to the right on the number line, and this is to the left on the number line, right? So if I want to do another one, right, and then I say, okay, well, if I'm going to graph these here, let's put a couple steps. So if I have a couple steps, I'm going to do some blue, okay, blue. First, we just need to identify a boundary, okay? Okay, so identify a boundary, and then 2 here. Okay, we'll talk about what this actually means, but we want to decide on inclusion. Okay, so decide on inclusion. So inclusion here, right? So if I have a symbol that looks like greater than or have a less than, okay, so those two symbols here, and I'll just leave them like they are, I guess. But that one you have, we would write and we would just say that it's an open circle. Okay, so an open circle. Maybe I'll just do open circle like this, and then you'll get to see it in a second. Okay, an open circle. And then if it's a closed circle, okay, so and this would be, sorry, this would be should have written this, not included, okay, right? Just so not included. And if it was included, okay, because if I say that I am older than 8 years old or something like that, right? And I say I'm older than 8, right? Then it's not possible that I could be 8 years old, okay? Okay, so this would be if I had this symbol or I had this symbol with that, right? Because this one means this first one, right? We could say that if I had right something over here, it'd say, okay, well, x, and I guess we'll just leave it like that for now, because I don't have room. Okay, but it's or this bottom thing right here means or equal to. Okay, so that means or equal to. If it's included, then we have what we say is a closed circle. Okay, and then we have a closed circle, and then the last thing we have to do is identify the direction. Okay, so we'll say identify direction. Okay, so right, review, right? So we said identify a boundary, decide on inclusion, whether it's open circle, closed circle, and identify direction. Okay, so let's go ahead and look at example 1 here. So example 1, they gave us this thing. They said, go ahead and graph this, right? And they said, I have x greater than 2. Okay, so first, right, and say divide the boundary, right? It's like, well, the boundary's kind of sitting there in front of me, right? It's the number 2. So when I make these number lines, right, I want you guys to make them very simple, okay? So very simple, right? Just go ahead and put a 2 right here in the middle and just label it 2, okay? Just label it 2. And then if I'm going to identify inclusion, I'm going to say, well, if I say x is greater than 2, right, then that means that it's not possible that x is 2, right? So x is just some number that I'm talking about, okay? So it's some values of numbers, okay? But anyway, x, okay? So when I draw this, I'm going to go ahead and say, okay, well, I want you guys to draw above the number line so that's easy to see, okay? And so I say, okay, well, I can draw an open circle, okay? And then the last thing is I need to identify direction, okay? Before I do that, let's go ahead and just, we'll put a 3 there, and put a 1 here, put a 0 over here, okay? I don't know. We don't really need to put very many points on this number line. Just make sure they're nice and spaced out so that I can see what's going on, right? So I have my open green circle, and if x right here is greater than 2, what numbers are greater than 2, right? And you say, okay, well, greater than 2, well, 1's definitely not, right? And 0's not, right? So that means I must be going to the right side, okay? So I'm going this way. Sorry, this arrow is bothering me. Sorry. Right? I'm just going this direction. Okay, and that's as simple as it gets. Or I guess as complicated as it gets, I guess is what I should say. For that one. And then if I went to example 2, It's a little bit different, right? But I'm just going to do x is less than or equal to 2, okay? So that's what this symbol is, right? It's less than, okay? So less than or equal to, okay? So less than or equal to, that's what that symbol there is, right? Pardon my handwriting with this pen here, but maybe I need to get a smarter pen here. I just have a, have an older iPad, so it just draws whatever you draw on it with a pen. Okay, so x is less than 2. So what was the first thing we did? Find the boundary. The boundary is sitting there right in front of us. It's the same as the other one, right? As the first example. So I say, okay, 2 is here in the middle. All right, let's go ahead and put 3 here. Let's go ahead and put 1 here. 0, 4, I'm done, okay? I don't need to put anything else. And then I decide on inclusion. Well, this one is going to be included, right? So if we go up here, right, say, okay, if it's included, right, then you say, oh, well, it's a closed circle, right? So what does a closed circle look like? Well, nothing too crazy, right? It's just going to be above the number 2 here, and I'm just going to fill in my circle, okay? You can be as big or small as you want, right? Don't make it too small, though, I guess, is my suggestion. And then we got to decide on the direction. So if x is less than 2, right? Well, 3 is obviously not less than 2, so I'm just looking at my numbers there. X is less than 2, I'm just going to go to the left side, right? So nothing too crazy going on. And then lastly, right? Well, I guess before I move on, right? You can see, right? I'm just following my steps here, right? If I have a boundary of 2, I just have to make sure I know how to read my symbols there. Okay, and this last one, this is just an example not in the book here, but I have an example here, and I have x is less than or equal to minus 4, okay? So this one's a little bit trickier, okay, because I x is less than or equal to minus 4? I'm like, what? Well, we know where our boundary is, right? Our boundary is minus 4. So I think about drawing this, right? If I go up this way, right? If I owe somebody minus $3 or minus $2, I'm owing them less money, right? But it's a bigger, it's technically a bigger number, okay? And this would be minus 5, right? Minus 6, right? And if I went this way, I'd be more in debt, right? So I technically would have less money if I moved to the left side of this graph. Okay, so now I got my boundary, right? Minus 4, I decide on inclusion, right? So that's my thing, right? Decide on inclusion. I don't have to strictly refer to this up here. I hope you guys can see, right? If I have that equal sign on the bottom, then hopefully you can see, right? That means that's including 4, right? Because it's x is less than or equal to 4, right? So I'm really doing the same thing that I did in my previous example. So I'm filling in my circle, and I say, okay, x is less than, right? If it's less than, it's always going to be to the left, just like my example up here, right? My first one, x was greater than 2, so I'm going to the right. X is less than, right? It's always going to be looking to the left. So this one's not complicated, right? I'm just going to take it from here, and I'm just going to go that way, okay? Just like that. And I think that pretty much covers it for this. If you have any questions, like I said, let me know. Attend the Friday session if you need any questions. It doesn't have to be topics that we covered today in the video. I think it's a pretty light week as far as new topics, but as you go through your lessons, tests, certainly let me know if you have questions. And I'll talk to you guys later. Bye.